Seth and I are some of the co-PIs that run Foldit, and we have worked together for several years on many different things in Foldit, but especially educational initiatives. And so we're going to talk about two of them today that have rather different goals. I'm going to start talking about education mode, and then Seth is going to talk about dojo mode. So first, I'm guessing this audience doesn't need much of an introduction to Foldit, right? I mean, it's another citizen science video game that's biochemistry focused. Of course, Foldit is primarily proteins. Started off as protein folding primarily when Seth first put this thing together way long time ago now. But now Foldit does all sorts of different biochemistry puzzles that are protein based, including protein design, solving crystalline cryo-EM structures, as well as now small molecule design as well. So I'm assuming that this audience does not need a huge introduction to Foldit, so I'm assuming that that's enough for most of you. What we're here to talk about today is more educational things. So these days, when you open up Foldit, this is the splash page that you get where you select what you're going to do. So campaign is the intro puzzles, science puzzles. Of course, the primary thing, Seth will talk about dojo mode here in the left-hand corner, and I'm talking about education mode up here in the right-hand corner. So education mode was something that Foldit we'd been talking about for a number of years. And then when the pandemic hit, it became a much higher priority because all of a sudden everybody needed really good educational tools that could be used online to teach science. And so many instructors had already been using Foldit in their classrooms, despite the fact that we didn't really have any real educational content that was designed for classrooms or anything similar. So Seth and I took it on with his graduate student, Josh Miller, to create education mode. And we decided to initially focus this towards the college classroom for what would be a first semester biochemistry class, thinking that others would want to use it as well, but that this seemed like the easiest place to start because the content fit very well with what you can do with Foldit. So this is the original version of Foldit education mode. We've since added a single extra puzzle. So this is 29 puzzles. And it takes you from the beginning of atomic interactions, which is 5 puzzles, then primary structure, which is the sequence of the protein. We have several puzzles there. We have to teach the tools to play Foldit as well as the science simultaneously. So we thread that in at this point. Secondary structure gets a number of puzzles. Then we have to make the transition to tertiary structure, and so we actually do that both from a primary structure and a primary structure, tertiary structure, and a secondary structure, tertiary structure perspective. And then finally, we finish off with some puzzles that are a little more functionally based. I'm talking about folding pathways for proteins as well as binding. So to give you an example of what this looks like, so here is a screenshot of one of these tutorial puzzles, and you can see that you have these little boxes that you click through. And in this particular puzzle, this puzzle is primarily about teaching people to use the wiggle tool, which is an optimization, a minimization procedure. But we take the opportunity to sprinkle in some science here even as well. And so we have an energy diagram. We talk about how you'll find your way into an energy minimum when you press wiggle. And so even when we're doing the automation methods, for example, we're still trying to figure out how can we connect it to the science education as well. And so this is all the way through education mode. So I just have a brief video. So this is, for example, what it looks like to play one of these puzzles. So this is me going and selecting a particular puzzle called primary structure. This was actually the first puzzle that I made for something that was Foldit or Foldit-like. I've had various iterations of this over the years, but this is a protein where all of the amino acids have been mutated to the same thing. And then in the puzzle, you have to change them to be more appropriate amino acids given their position in the protein and the surrounding environment. And as you can see up top, the score is going up as you get more and more of your of your protein to have reasonable amino acids. And so this can teach people about concepts of things like hydrophobicity and hydrophilicity, as well as hydrogen bonding and all sorts of other different properties. And so that's just one example to give you a little bit of flavor. Now, does this work? So this is a bit of unpublished data. It's currently under review. We did a controlled study where we had one group play Foldit Education Mode for 7 weeks, and we had another group that was learning biochemistry through online lectures and textbook. And I should say that this was not a group of students, biochemistry students. These were lay people who were just interested in learning science. And what we can see is that the Foldit group, when we compared the post-test score to the pre-test score, the Foldit group did far better than those that were using other online tools for learning, and it is highly statistically significant as well. And so even when people don't have a great biochemistry background, they're able to use Foldit to learn biochemistry in a way that's much better than the other tools that were readily available for them to learn this sort of material. And with that, whoops, why is it not letting me go forward? So just a few things about now and in the future. So since we released Foldit Education Mode in 2020, it's been used by many, many thousands of students, and probably over 100 instructors that I know of, and probably many more that I don't. And not just at the college level, but the high school and middle school level as well. Many of these have not been college biochemistry students like the people I was talking about in that study, who were just people who were interested in learning about science and were able to do it using Foldit Education Mode. And now we're starting to work on a new version of Education Mode, really targeting those people who are not trying to become, science majors, but who just want to learn the basics. And so it's going to be targeted differently. It can be used, for example, in classrooms earlier in the education, or by people who don't have a strong science background. And so that version is currently underway. And so with that, I will end my little bit and let Seth take over. And then we will jointly answer questions, presumably at the end.
So I'm going to talk about this matchmaking in this Foldit Dojo mode, which is not entirely education related, actually, but maybe could be. And so this kind of approach that I'm going to talk about actually goes back to something outside of Foldit. There was another kind of citizen science crowdsourcing game that we were working on called Paradox. It was also a puzzle game. You tried to use various tools to solve puzzles. And when we were working on this, we had a whole bunch of levels basically that we wanted people to solve. And we had the question, what level should we serve to a player, right? If a player finishes a level, win or lose, what should they do next? We have this huge sort of pool of levels that we wanted to serve out to players, and we wanted to make it not give them something too hard, not give them something too easy. Is there something that we could do that was better than just kind of picking something random and giving it to the players? So for this, we kind of drew inspiration from existing player versus player games, right? Where you have, right, in this case, we didn't know how hard the levels were, we didn't know how good the players were. So there are other systems kind of that have been developed in games for doing this kind of matchmaking, where you don't kind of know the skill level or challenge level of things, which are these sort of player rating and matchmaking systems. But they're usually used for player versus player matchmaking, right? So if you're familiar with chess, you might have heard of ELO, or Halo. There's True Skill, right, is one that's used a lot for online game ranking and matchmaking and that kind of thing. So there were already basically these kind of systems for matching players with each other. And in this project, we basically drew inspiration from those to do a player versus level matchmaking, essentially, right? So instead of matching players up with other players, we matched players up with levels that we thought would make kind of an interesting match, and basically the same way. And so in this work, we compared a couple different systems, but we kind of ended up going with this rating system called Glico2, which is fairly similar to ELO in a lot of ways. So, but it has a couple advantages over it, basically. And essentially, we kind of built the system where you could treat levels as though they were players, and then do matchmaking on them, right? And whenever a player attempts a level, that's basically a match, right? So the player attempts a level, and that's kind of the equivalent of in a player versus player system, two players competing. And then we could use the resulting ratings to do matchmaking in roughly the same way that you might do for player versus player matchmaking. And the kind of at a high level, the two things that we use out of these rating and matchmaking systems, or rating and matchmaking systems, is that for any two kind of things in the system, usually that would be two players, but here we have a player and a level, we can take their rating and we can get some sort of estimate of how likely the player is to win against a particular level, right? So roughly speaking, usually if they have like the same rating, it's like going to be 50-50. And if the player, as the player's rating gets higher than the level's rating, their probability of winning, you think kind of goes up. And then generally there's some way of like updating the ratings after a player attempts a level, or, two players play against each other if it were player versus player. But in this case, it's like player versus level. So if the player wins, their rating will go up and the level's rating goes down. And if the player loses, the player's rating goes down and the level rating goes up. And so in this way, it's kind of like over time, you get, a better estimate of kind of the skill level of the player and maybe what we might call like the difficulty of the level, right? Levels with higher ratings are more difficult, and players with higher ratings are probably more skillful. And it can change over time too, right? As well, right? And then since we were doing player versus level matchmaking, right? We kind of found that you can basically adjust sort of like the probability that you want the player to win as they get better. If generally speaking, roughly, if you're doing player versus player matchmaking, you probably want like a 50-50 match, right? You want players who are closely ranked, right? So that the outcome is maybe a little bit more uncertain. But since this is finding levels for players to play, we don't really worry too much about the levels, right? If the levels want to win or not. So we actually found kind of this logistic curve that seemed to work reasonably well, or this kind of difficulty curve where essentially as the player rating goes up, we can reduce the probability of them, the expected probability we want them to have a winning. So in fact, when they start, it's very high. Like I think we generally start around like 95% on a curve like this. And then as their rating goes up, essentially the probability that we want them to win the next level kind of goes down. And if their rating goes down, the probability we want them to win the next level goes up. And so it's kind of adaptive in that way. And even if this was a flat kind of thing, it can be adaptive as well. But this kind of makes it harder, faster, essentially. And we have looked at like various curves as well, and I'll talk a little bit about that too. Yeah, so as the player wins, right, their rating goes up, and to find a level, basically once we know the win probability that we want, like say we want to find a level that we think the player will have a 95% chance of winning or something, we can just go through all the levels, compute the probability, and pick the closest one. So this is like an example here. This is not from Foldit, this is from Paradox. But the dots are the level rating and the line is the player rating. And so green means they won, red means they lost, and yellow means they skipped it. So roughly speaking, what's showing here, right, is the player wins, their rating goes up, and the ratings of the levels they play goes up. When they lose, they go down, and then they skip and they quit. So that we had seen that this worked in other games, and we wanted to try to see if we could sort of use the same approach in Foldit. So we built this area in Foldit that you can get from the main menu called the Foldit Dojo. It's supposed to be kind of like a training area where you can practice and see how far you can get before you get to levels that are too hard to complete. And so basically underlying this is kind of the same system that I was just describing before, except in Foldit. One thing that we did have to change is that in Foldit, there was really no way to like lose a puzzle, right? You just play until you kind of give up. So to kind of get this to work with the matchmaking and rating system where you need kind of like a win or a lose, we added stamina, which basically kind of decays over time or as you make moves. So you kind of have a limited amount of time and moves to make a level. And if that runs out, then you lose. That counts as a loss. And of course, if you finish the level, you win, right? And so in when we were looking into evaluating this or seeing how it worked in Foldit, we actually had 71 levels who had their ratings initially set heuristically. but then the ratings of the levels were updated from players playing in the similar way that I described before. And we did kind of we want to see how well it worked or what impact it had, or if it worked in Foldit at all, because we had seen it works in other games. We tried a couple different ways of ordering the levels within the dojo, and got some data basically on how people went through the dojo with these different approaches. So one was linear, which is basically just going from the easiest level to the hardest, just sort of strictly increasing. Random, which is just randomly giving people a level from one they haven't played yet. Logistic, which is this kind of difficulty curve where as players get better, we want the probability of them winning to go down. And then we also tried this sort of like fixed probability where they had just like a reasonably high probability expected of winning throughout the whole time, didn't change regardless. And I guess I can sort of go through the plots relatively quickly. Basically, in terms of how long people played, with the logistic curve where it got harder as they got better, people spent a little bit more time playing than random, but the other ones were not like different from each other. People, generally speaking, random was worse than the others in terms of number of levels completed, and the logistic curve was a little bit better than the fixed curve. And in terms of the highest level that players were able to beat, random was worse than the others. And if we looked at how high of a rating players were able to achieve, there wasn't really any difference between them. So when we saw this, right, we looked at a couple of things that could see how players did in the different ways of ordering the levels. And generally speaking, random was kind of worse than the others. So there's maybe some information and some usefulness for ordering the levels based on this information. The other three were fairly similar in most cases, although the logistic curve that got harder faster did seem to improve a little bit on some of the other things that we looked at. And even linear, just the linear increasing order of levels was still using the level ratings that were learned from this system, even though it wasn't adapting sort of or adjusting to individual players. So yeah, the Foldit Dojo basically is using rating and matchmaking. It was potentially useful in Foldit, a game that is kind of online. All the previous kind of work we had done with this was looking at kind of games where we were finding people to play them just to look at the effects of the matchmaking system. But here we built this separate area into the existing game of Foldit. There's definitely more work to do. For example, it would be maybe interesting to integrate this into the scientific puzzles. This was kind of a separate area, separate from the scientific puzzles. And we think it would be interesting to, integrate it into that, so that, maybe occasionally, if you're at a certain level of skill, it might end up recommending that you would play a scientific puzzle for a little bit and then go back into the training, something like that. So there's some work to do to kind of integrate it into that aspect of Foldit. And like in general, it seems like a fairly flexible approach. We've tried it in a couple different games, at a high level, kind of, you just need a game where players play levels and they can win or lose. So we've tried this out in various forms in a couple different games, and it seems to work reasonably well when compared to kind of like baselines. It might be useful for educational aspects and trying to find where should players go next, and in a kind of more adjusting to particular people and how well they're doing. And I think it could be applied to games where the content is like procedurally generated or player generated, where because one of the neat things about it is that it can figure out kind of how difficult the levels are without really much input or any input to some extent from the designer of the game. So thanks. Here's some information about me, and I want to thank the students who did the work on this and that kind of thing. If you want more information, there's the paper about how we integrated into Foldit, and then also is kind of the original kind of evaluation of the system from a few years before that. So yeah, thanks.